Okay, so our lesson today is classifying triangles. Again, this is lesson 4.1. Let's kind of take a look at the objectives for this lesson. So our main objectives here are for us to be able to classify triangles. We're going to talk about the different types of triangles, and then we're also going to be able to use the classifications to find both angle measures and the lengths of sides of the triangles. Okay, so let's start basically talking about a triangle. This chapter 4 relates to triangles specifically. We know that a triangle, you've probably been looking at triangles since you were in elementary school. Basically, it's a polygon that has 3 sides. It can be classified using the sides or the angle measures. If I'm looking at a picture of a triangle here, I've got 3 sides, so AB, BC, and AC. 3 vertices. The vertices are the vertex of each place where the lines intersect. There are 3 of those. Important for us to be able to write using the symbol. So, now if it's a triangle, we use this little symbol in front instead of the angle measure. So knowing the difference between these 2 things, this would be angle ABC, this is triangle ABC. So that's important. Let's go ahead and start with our classification by the angle. So I'm just going to kind of go through. There are 4 of these. The first one is an acute triangle. We know an acute triangle has 3 acute angles. That means that all 3 of the angles are less than 90 degrees. And again, this slideshow is there on your calendar if you're wanting to follow along or if I go too quickly through this. But acute triangle, all 3 angles less than 90. The second one would be what we call an equiangular triangle. Now, an equiangular triangle has 3 acute angles, and they are all the same measure. So we would say that all 3 of these angles are 60 degrees, because we know that all three angles in the triangle add up to 180 degrees. Equiangular triangle would also be considered acute because all the angles are less than 90. Okay, the third one is a right triangle. Right triangle contains 1 right angle. Again, it does have to have this little box for us to know that it's got a right angle in it. That's the main indicator there. All of the other 2 angles here would be acute. They've got to be less than 90. Together, they would add up to 90. Our 4th type of angle with relation to the angles is considered an obtuse triangle. We say that an obtuse triangle has 1 obtuse angle. That means that this angle here in this picture would be bigger than 90. And then the other 2 angles, again, would be acute angles, just pretty similar to the right triangle. Okay, let's take a look at a few examples where we're classifying the triangles by their angles. So in this first one, triangle BDC. So notice we're looking at this triangle right here. The 100 is this angle in the picture there. We know if that's 100 and this is 10, that this angle here has to be 70. So with that being said, can somebody tell us what kind of angle we're looking at there? Acute, right, obtuse, or equiangular? Matt, can you tell us what kind of angles those would be? Or what kind of triangle we would have? And your choices are acute, obtuse, right, or equiangular.
Right angle.
Now we're looking at this triangle here. So it's 100, 70, and 10. There's not a right angle in there, so we wouldn't say it's a right triangle. We would say it's a, what's the 100 degrees tell us?
It's right. It's over 90.
Well, if it's over 90, it can't be a right triangle. It's got to be 90 for it to be a right triangle. So which one of these has an angle that's bigger than 90? So we've eliminated, it can't be right and it can't be equiangular. So is it acute or obtuse? It would have to be obtuse, okay? Let's look at the same picture, but let's look at a different triangle. Now they want us to look at triangle ABD. ABD would be the small triangle in the picture. Again, we know if this angle is 20 and this is 80, this other angle here has to also be 80. So, Lucas, what kind of triangle would we have here on this one?
Acute.
This would be an acute triangle. Excuse me. Excuse me. Let's do one more. On this one, they want us to do triangle FHG. So this is 60, this is 60. That would make this also 60. So Hayden, what kind of triangle would we have here?
Equilateral.
Okay, it is equilateral. We haven't talked about equilateral yet, but it would be, by the angles, it would be equiangular. Okay? All right, let's go ahead and talk about our triangles by the sides, classification by the sides. So we just mentioned the word equilateral, so notice the difference. Equilateral, we're referring to the sides, and that basically means that all three of the sides are the same. Believe it or not, what she just said is true, that if we do have an equiangular triangle, the triangle is also equilateral. So that means that all three of the sides are going to be the same if all three angles are 60, or if all three angles are 60, all three sides are going to be the same. That's equilateral. The second one is an isosceles triangle. We say an isosceles triangle, this is a triangle that has at least two congruent sides. So we could consider an equilateral triangle to be an isosceles triangle because it does have two congruent sides. So two congruent sides. One of the things I'll point out with an isosceles triangle is these two angles opposite of the congruent sides are called base angles. And the base angles in an isosceles triangle are congruent to each other. So something you might want to include when you're marking your picture there with isosceles. Okay, our third type with the sides would be a scalene triangle. We say that a scalene triangle, this is a triangle that has no congruent sides, which basically means that all three of the sides have a different length or a different measure. One of the things that I'll point out to you is that when we're looking at classification by the sides, it is important for us to know that the markings on the triangle are really important in terms of our determination. So if I gave you a picture that looked like this, and it has no markings on it, even though it looks like an equilateral triangle, we couldn't determine that based on the information. Now, if I said this, now we know that we've got two of the sides that are the same, so we could consider it then to be isosceles. So important, again, to know the markings and not to assume information that's not true. Okay, let's look at a couple of classifications before we look at a couple of algebra problems. The first one here, we've got triangle EHF. EHF. We've got two markings on the triangle EHF. John, what do you think? What kind of triangle EHF based on the sides?
A right angle.
Okay, now remember, if we're going to assume this is a right angle, we need to see a little box in here. We don't have a box, so we can't assume it's a right triangle. Based on the sides, is it equilateral, isosceles, or scalene?
Scalene.
Okay, now scalene means that none of these sides are the same. Wouldn't you agree these two here are the same based on the markings?
Yeah.
Okay, so in this triangle, this would end up being an isosceles triangle. All right, let's look at another one. EHG this time. So now we're looking at the same picture, just the big triangle in the picture. Macy, what kind of triangle you think EHG would be?
Adjacent.
Say it again.
Adjacent? I'm not sure.
Your choices are equilateral, scalene, or isosceles. It would be scalene because this is 12, this is 11, and this is 14. So all three of the sides are different lengths. So therefore it would be scalene. Okay. Let's do one more. Triangle ABC in this picture. Triangle ABC. Kendall, what do you think? What kind of triangle would ABC be?
Would it be equilateral?
It would be equilateral because we know that all three of the sides there are the same length. So they would all be 15 there. Very good. Okay, let's look at one problem today where we're doing some algebra. Make sure we're good on those, and then we'll kind of wrap things up here today on our lesson. So in this next one, we've got triangle JKL, and they want us to determine the length of each of the sides. So again, the markings are going to indicate how we set it up. If it's equilateral, we know we're going to set, you can set any two sides the same. Notice in this one, these two lines are marked, so we can consider this to be an isosceles triangle. So what I'm going to do on this one, since it's isosceles, and I know these two are the same, I'm just simply going to say 4x minus 10.7 is equal to 2x plus 6.3. And pretty similar to the problem we did earlier, we're going to get our x's together, and we're going to solve it. So when I get my x's together, I'm going to subtract 2x from each side. I get 2x minus 10.7 equals 6.3. And if I take that and add 10.7 to both sides, I get 2x equals, let's see, 0. Looks like it's going to be 17. And if I take that and divide by 2, x is going to be 8.5. Now they're not wanting to just know the value of x, they're also wanting us to find the values of each of the three sides. So let's talk about how we do that here real quickly. We're going to take the 8.5 and we're going to sub it in for each of the x's. So go ahead and do that right now, and then we'll talk about what the answers would be. Okay, so we do a quick check. We're going to, like I said, put 8.5 in for each of the x values. You'll notice on these top two lines, when we do that, 2 times 8.5 plus 6.3 gets us 23.3 and 23.3. And then the other one gets us 44.5 when you plug that in.